Hello, all folks. So today I'm going to do a short little talk about how I fixed a non-working dryer, a broken dryer. The LG dryer was no longer heating the clothes, so I made a small project why the LG dryer was not drying the clothes and all. So what I did was I'm going to explain to you very basic steps. If you are especially a homeowner in United States or elsewhere, you might want to understand how these electric things works. It's very small things, but if you understand, and if you're a handy person and if you want to kind of fix these things yourself and want to understand how these components works, it's a very short video, but it's very useful, especially for the homeowners in United States, right? And so I'll quickly tell you what the problem was, and then we will go through this statement. So we have this LG dryer which was not heating the clothes, and it's just the clothes just keep drying, right? So in the circuit diagram, if I just put here, there's a LG dryer, there's a electrical outlet. You have the initial one you see is a heating element, and then which passes on the heat to the thermal fuse. The job of the heating element is to take the power from the outlet, heat it, and then pass the heat to the thermal fuse. And if the thermal fuse can take a maximum of 300 degrees Fahrenheit, the heating element takes a maximum of 250. If it goes beyond 250, it's going to blow, and then it's going to pass more heat to the thermal fuse, and thermal fuse will blow away if it goes beyond 350, and that's the way how it works. So anytime this thermal fuse breaks, it is very likely the heating element is also broken. So you need to replace both the parts instead of fixing only the thermal fuse, which I did earlier. If you just fix the thermal fuse, because the heating element is already broken, it's going to again blow away the thermal fuse, right? So this is the way how this project thing works, and I have detailed steps how to use a multimeter. You can use a multimeter and check each of these components, whether the resistance, what is the resistance, ohms, how much is taking, and is it a good one, which are the components failed, and also in the in the chain of the videos that you see. Okay, all right, talk to you folks. Bye bye. Okay, so we are trying to do a small project on a broken dryer. I have two parts right in front of me. One is a heater element. This is the one, L365, this one number, and there is a fuse, thermal fuse, it's called as. So what happened was, these are good ones. So, but what happened was the thermal fuse was, the heater element was sending too much of heat into the thermal fuse and broke the thermal fuse. So this was originally broken when broke the thermal fuse. So the project is to show you what is a good thermal fuse, and you can see in the multimeter right now it's reading is, I believe, yeah, I'm just trying to touch some elements here. Yeah, you can see like it's currently reading as 10, like, you know, I think possibly maybe I need to flip this way. You see full picture of it. Hope. Yeah, you can see a clear 10. Oh, come on, pull it down. So yeah, this is a this is the multimeter, right? Sperry multimeter. And now you see how I'm going to touch both of these terminals. If you see here, I'm touching both. One is the red and one is the red and one is the black. And if you touch this, if it's a full circuit and a good one, it's going to read the numbers like a lower number. So there's a lesser resistance. If zero resistance, it's dead, but you need to have at least some amount of resistance. As you can see, I think the current resistance is around at somewhere, if I'm not wrong, yeah, it's reading at 0.5 or some kind of resistance. So this is a newly got it from Amazon, and so you can see clearly that this is conducting well, and it's a small kilowatt level. Okay, so this is looking good. Okay, same way, let's check the thermal fuse. So I'm trying to show you what is a good versus bad. Like if a dryer broke on you, then you'll know, you can yourself check it out. It's no need to try to understand, like, what part broke. And you can see even this is like reading at a kilo ohms, KQ, So this is running at 3.7 kilo ohms, right? So it's a low number, it's not a ton of number. If you something see like a megabyte, it means like there is a huge amount of resistance. But if you see just like a just few ohms or kilo, but something, it should be, so circuit is working clearly and it's all working good, right? Now I'll show you the broken parts. Okay, these are the good ones. I'm going to keep it aside. The ones that broke, so these are the ones that broke. Okay, the one, and you can see this again, the same parts from the same dryer. So how the broken parts will read like something like this. So this is the thermal fuse. Okay, now if I do the same thermal fuse here, you can see I'm touching the red and black. You can see how when I touch it, the number doesn't change. It's standing exactly as if it's dead. So the circuit is dead on this, and this is broken. This is a blown fuse completely. And now if I do the same thing on the heater element, you can see here. So the heater element is showing me some good amount of reading. I mean, it's not like it's good reading, but the problem is right now this is not heated at 380 Fahrenheit or something like that, because right now it's at a room temperature. At the room temperature it is conducting well, but when it's heated up, it doesn't cut off. This is like a cut off switch, and it doesn't cut off. Okay, that's a problem. Okay, so now we are going to install these two parts, the thermal fuse and the heater element, and then see how the dryer works. Currently the dryer doesn't blow. Okay, I'm going to end the video here, and then I'm going to do another one once I install both the parts. Okay, all right, thank you. But I hope you understand how to check the ones that broke versus the ones that did not broke. Especially this one, you can clearly see this is broken because this is zero conductivity. There's nothing. The circuit is broken. The fuse is blown. But the fuse is blown. The reason is because this guy was sending a ton of heat into the thermal fuse and caused the breakage. So instead of breaking at a cutoff point, he would send a ton of heat into this. Okay, all right, I'll end the video. Thank you so much. Now you can see how yeah, you can see how there is a thermal fuse. Okay, like the one on the left is a thermal the heater element, on the right is the thermal fuse. So we're going to install the parts on that. Then there are connectors here down, which you possibly cannot see, but the red and yellow wires, you can see that one. Okay, so I'm just going to cut off the video here. Okay, all right, now you can see how I attached on the left side. You can see the heater element, and the right side you can see the thermal fuse, and the red is on the top, the red is on the top and the white is on the bottom. And now it looks all good. I just put one screw each on the top. I tightened them good enough, and I think I could have been left with one more screw if I'm not wrong. Maybe I'll try to screw in the other one too. But the connections are all made. I checked the resistance as well. Looks perfect. And I'm going to start the dryer, and let's see if it heats up. Okay, I'm going to attach a couple of screws, but I think once it produces the heat, so we already know it's on the way. Okay, all right, I'll take a break here. The heater is working, and as you can see, I'm touching the heater. It's very hot. So looks like the fix happened, and I think that's a good way to make the heater work. So this is an LG Trom heater, and yep, it's all fixed up. Okay, thank you, thanks for listening. Finally, you need to ensure you connect the hose in the back, right? So where the lint goes in. So I connected that, then connected the electric connection, right? And then so it's working good. I mean, just ensure that it runs good and then produces the heat. That's it. Like, we're done with the project. Thank you. This is the vent from where the heat blows. So and the last thing you want to do is you turn on the dryer, whether it's working or not, and then maybe climb up a ladder like I am right now. So you see how I can feel the very hot air coming out, blowing here, and on top of that, see how the metal is flipping there. So which means there's a lot of air coming out, and that's a good sign, a hot air and the metal plate flipping. So this is exactly how you test if the dryer is working or not. So yep, what might come handy is a magnetic tip husky driver set. So this has a magnetic tip up there to hold, to reach to the screws inside, and then a multimeter without which you can't do this project. Okay, so these are the two important tool sets you begin before such projects. It's a very, very simple science based project, I can say. Like, you can do this almost at any appliance, whether it's a microwave, refrigerator, and doesn't matter, whatever it is, but anything that induces the current and all.